Yep, I am live and my screen is already stuck. I will have to remove it and put up a new screen. And it has been some time since I last streamed, and it has been like 2 days since I streamed. I had my college exams, and that is just a pathetic excuse for not streaming. And yep, pathetic, pathetic and shitty excuse for not streaming every day. But well, at least I'm now showing up, and yes, we'll take it from here. Where is the book? Uh, Unix operating system. Where is the book? History. Oh, shit. Can we see? It is in books itself. Like here, right here. Yep. I guess this one. Yep, that is it. Chapter 4. Here we are. We had to begin this chapter 4, and yeah, let's just begin. This stupid audiobook version. Well, the book is not stupid. My version of it is sixth edition, 1975. It came out in nine. It started being built in 1969 or 70 at PDP 5, and now sixth edition, 1975, and we work from here. The number of Unix installations has grown to 10, with more expected. Okay, the number of Unix installations is now above 50 after 2 years, and many more are expected. The first edition of Unix was up and running by late 1971. If we go by the date on the manual, for the next few years, there was a new edition of a manual roughly every 6 months, each time with major new features, new tools, and new languages. The sixth edition, whose manual is dated May 17, 1975, was the first that found its way outside of Bell Labs to any significant degree, and it had a major effect on the world. Unix was the first publicly described. Unix was first publicly described in a paper by Dennis Ritchie and Ken Thompson. The Unix time-sharing system that appeared on the fourth AMC symposium on operating system principles in October 1973. It was republished with the minor changes in the journal Communications of Association for Computing Machinery CACM in July 1974. The abstract begins with a concise summary of a remarkable number of good ideas. Okay, Unix is a general purpose multi-user interactive operating system for the Digital Equipment Corporation PDP 11 to 40 and 11/45 computers. It offers a number of features seldom found even in larger operating systems, including a hierarchical memory incorporating demountable volumes, a hierarchical file system incorporating demountable volumes, hierarchical file system, demountable volumes, compatible file device, and inter-process I/O, compatible file device, and inter-process I/O. Okay, the ability to initiate asynchronous processes. Okay, system command language selectable on a per user basis. System command language. And okay, we have a chapter for each subsection and chapter for each, and then over 100 subsystems, including a dozen languages. Okay, a dozen languages, that is a lot of languages. What were these features? Seldom found even in a larger operating system, and what was their significance? The next few sections talk about some of them in more detail. If you are not technically inclined, you can safely skim the chapter. I have tried to summarize the important parts of each section near the beginning, so you can skip the details. File system. The file system is a part of an operating system that manages information on secondary stage like disks, okay, which for many years were sophisticated mechanical devices based on rotating magnetic media, and which today are most often solid state disks or USB flash drives, integrated circuits that have no moving parts. Yes, we are familiar with the abstract view of this information storage through programs like Explorer on Windows and Finder on macOS. Underneath those is a significant amount of software to manage the information on physical hardware, keep track of where each part is, control access, make it efficiently accessible for reading and writing, and ensure it's always in a consistent state. Okay. Before Multics, most operating systems provided at best complicated and irregular file systems for storing information. The Multics file system general, was much more general, regular, and powerful than other file systems of the time. But it was correspondingly complex. The Unix file system that can developed from mm, profited from Multics, but was significantly simpler. Its clean, elegant design has over the years become widely used and emulated. A Unix file is simply a sequence of bytes. A Unix file is simply a sequence of bytes. Yes, any structure or organization of the content of a file is determined only by the programs that process it. Yep. The file system itself doesn't care what's in a file. That means that any program can read or write any file. This idea seems obvious in retrospect, but it was not always appreciated in earlier systems, which sometimes imposed arbitrary restrictions on the format of information in files and how it could be processed by programs. Doug McElroy described one example. Yep, what did he describe? He said that typically source code was a distinguished type. Source code was a distinguished type, different from data. Source code was a distinguished type, different from data. Compilers compile could read source. Compiled programs could read and write data. Okay, compilers could read source code and compiled programs could read and write data. Thus, the creation and inspection of Fortran programs was often walled off from the creation and inspection of other files with completely different ways to edit and print them. This ruled out the use of programs to generate or even simply copy Fortran programs. To even simply copy Fortran programs. Okay. Unix made no such distinctions. Any program could process any file. If applying a program to a file doesn't make sense, for example, trying to compile a Fortran source file as if it were C, that doesn't have anything to do with the operating system. That is the fault of the program that is trying to do a stupid thing. Unix files are organized in directories. Other operating systems often call these folders. A Unix directory is also a file in the file system, but one whose contents are maintained by the system itself, not by user programs. A directory contains information about files which may in turn be directories. A Unix directory is also a file on the file system, but one whose contents are maintained by the file system itself, not by the user. A directory contains information about files turn which may be in turn be directories. Okay, so literally everything is just a file. So a directory is also a file which contains information about the files that it contains, which can in turn be other directories which contain information about other files and directories which are contained in that subdirectory. Okay, a Unix directory, a Unix directory entry includes the file name within the directory. A Unix directory entry includes the file name within the directory, access permissions, file size within the directory, access permissions, file size, date, and time of creation and modification, and information about where to find the contents of the file. Each directory has two special entries named dot, which means the current directory, the directory itself, and dot dot, the parent directory. These are produced at dot and dot dot. The root directory is the top of this hierarchy. Its name is slash. Any file can be reached by following the path down from the root, and the root can be found from any file by going up a sequence of parent directories. Thus, the text for this book might be found in user BWK Brian W. Kernighan slash book slash book.txt. The system also supports the notion of a current directory so that file names can be relative to the current location in the file system. So that relative file names can be relative to the current location in the file system rather than having to specify a full path from the root. Okay. Because any directory can contain subdirectories, any directory can contain subdirectories, the file system can be arbitrarily deep. Okay. This organization of nested directories and file system is called a hierarchical file system. Again, though the advantages are obvious in hindsight, hierarchical file systems were not widely available before Multics and the Unix. For example, some file systems limited the depth of nesting CTSS sharing system, time time sharing system, complementary computed compulsive complementary time sharing system, limited it to two levels. System calls. An operating system provides a set of services to programs that run on it. Services like starting and stopping programs, reading or writing information in files, accessing devices, and network connections. My bad. Starting and stopping programs, reading or writing information in files, accessing devices, and network connections, reporting information like date and time, and many others. These services are implemented within the operating system and are accessible from running programs through a mechanism called syscalls. A program can do syscalls to tell the operating system to do something for the program. I hope my screen is not stuck, which it is not. So we can just move on. And yeah, in a very real sense, system calls are the operating system. Uh, because they are the interface through which programs interact with the operating system. So, in a very real sense, system calls are the operating system since they define what services the system provides. There may be multiple independent implementations of a set of system calls, as is the case with different versions of Unix and Unix-like systems. A completely different operating system, say Windows, could provide software to convert Unix system calls on its own system calls, and there are sure to be system calls that are a there are sure to be system calls that are unique to a particular operating system, even if it is Unix-like. Okay, system calls depend on the operating system, not the goddamn processor. Well, to call a system call, that is, I guess, specified by the processor, but the system call numbers are specified by the operating system. The first edition of Unix had just 30, over 30 system calls, about half of which were related to the file system because files contained only uninterpreted bytes. The basic file system interface interface was dead simple. Only five system calls to open or create a file, read or write its byte, and close it. There were These were accessed from a C program by calling functions using statements like this: ft equals to create, open file and mode, read, write, and then close. The create system calls creates a new file and sets its access perms, which normally would include or exclude the ability to read, write, and execute for the users group and for everyone else. These 9 bits give considerable control with comparatively little mechanism. The open system call opens a file. An existing file mode specifies whether the file is to be read from or written to, and file name is an arbitrary path to the hierarchical file system, which can be relative or absolute. The fd value that results from calling open or create is called a file descriptor. A file descriptor, yep. A small non-negative integer that is used in subsequent reads and writes of the file. The read and write system calls attempt to transfer n, a specified number n of bytes either from the file or to the file. Each function returns the number of bytes that were actually transferred for all of these system calls. If negative value is returned, that indicates some kind of error. By the way, the create system call really is spelled that way for no good reason other than Ken Thompson's personal taste. Rob Pike once asked Ken what he would change if he were to do Unix over again. His answer, I would spell create with an E. Create with an E. Another Unix innovation was to have peripheral devices like disks, terminals, and others appear as files in the file system. Disks are the demountable volumes mentioned in the list of features. The same system calls are used to access devices as are used to access files. So the same code can manipulate files and devices. Of course, it isn't that simple since real devices have wired properties that must be handled. So there are other system calls for dealing with the syncrasies, especially of terminals. This part of the system was not pretty. There are also system calls for setting a position within a file, determining its state and the like. These have all been embellished and occasionally improved over 50 years, but the basic model is simple and easy to use. And this chapter is a bit. Wait, who is that? Doug McElroy. This chapter is a bit long, till page number 85, and currently we are at page number 14 here. We are at page number 65. We have 20 pages to go. That is just crazy. Okay, well, it is like kind of obvious that I will not be able to complete this chapter, which would be mm, unsuccessful. Unsuccessful, even if I tried, because I am sleepy and yeah, I got some other stuff also, but I will have to do 50% of it at least, and let's just do it. It may be hard for today's readers to appreciate just how much of a simplification all of this was in early operating systems. All of the myriads complexities of real devices were reflected through to users. One had to know all about disk names, their physical structure, like how many tracks and cylinders they had, and how data was organized on them. Steve Johnson reminded me of how awkward it was with the time-sharing subsystems on the main Honeywell computer at this time. The Honeywell TSS system required you to enter a subsystem to create a disk file. You were asked about 8 questions: initial size of the file, maximum size, name, device, who could read it, who could write it, etc. Each of these had to be answered interactively. When all the questions had been answered, the operating system was given the information, and likely as not, was given the information, and likely as not, something was mistyped and the file creation failed. That meant you got to enter the subsystem again and answer all the questions again. It's no wonder that when a file finally got the system successful, Unix followed the example of multics and hiding all this irrelevant nonsense. Files were just bytes. The user determined what these bytes were, while the operating system looked after storing and retrieving them without exposing device properties to users. Shell. The shell is a program that runs other programs. It's the program that lets users run commands and in the primary interface between users and the operating system. When I log into a Unix system, my keyboard is connected to a running instance of the shell is connected to a running instance to a shell, and shell is just a program. To the shell, I can type commands, usually one at a time, and the shell runs each in turn. And and after each one is completed, it's ready for the next. So a session might look like this, where dollar is a prompt that the shell prints, so I know it's wanting for me to do something. What I type in is this slanted font. Tell me the date, this uh, made the shell gave me the date, then ls gave me the books, then wc text.txt count lines and the words and characters in book one. This cp copy text book.txt to backup.txt copy book.txt to backup.txt. One very important note: the shell is an ordinary user program, not some integral part of the operating system. And another idea from Multics. This is the system command language selectable on per user basis mentioned in the feature list. Because the shell is a user program, it's easily replaced by different ones, which is why there are so many Unix shells. If you'd like the way one shell works, you can pick another, or even write your own and use it instead. Speaking of the shell, it is not specific. And that said, that all Unix shells provide the same basic features, usually with the same syntax. The most important feature is to run programs. They also provide file name wildcards, which where pattern matching, like regular expression, are expanded into a list of file names that match the pattern. For example, to run the program WC word count to count the files, words, and characters in all the files in the current book directory whose name begin with book one gives the command this count words for the place where books are stored. They gave in the reference. The shell expands the pattern book into all the forms in the current directory that match any name beginning with book and runs WC with those names and arguments. The C command itself doesn't know that the list uh, know why they want me to force quit this. It's important that expansion is done by the shell, not by individual programs. For many years, Microsoft's DS MS-DOS operating system didn't work that way, and so programs did their own expansion, and others didn't use couldn't count on consistent behavior. Another major service of the shell is input slash output redirection. If a program reads from the standard input by default the terminal, it can be made to read an input file instead by this. And if it writes to the standard output, again by default, the terminal, its output can be redirected into a file. Yep, like this. The output file is created if doesn't exist already as a file name expansion. The program doesn't know that its input or output is being redirected. This is uniform mechanism applied by the shell, not by the individual programmers programs, and either to the use the approaches like specific file input and output. My absolute bad. Approaches like specific file input and output by patterns for file names, as in program in file equals this and output equals this. A shell script is a sequence of commands that have been stored in a file. Running an instance of the shell with this file is an important with this file as the input runs the command of the script as if they had been typically directed. Scripts. I feel very, very sleepy right now. And I guess, yep, I gotta do till pipes at least. And then I have my algorithm books by Corwin, the algorithms book, the introduction to algorithms by whose co-author is also Ronald Rivest, who's MD5, who created, invented, or discovered, whatever you want to say, the MD5 algorithm and RSA algorithm, and they both have RFCs, their own RFCs. Now, a script encapsulates script. A script encapsulates a command sequence. For example, for this book, I run a sequence of simple checks that look for spelling and punctuation errors, improper formatting commands, and other potential gaffes. Each of these checks a program, runs a program. I could type the command over and over again exactly script uh, over and over again exactly the same each time. But instead, I can put the sequence of commands in a single file called check, and thus can check the book by running a single command. Other files, other scripts print the book and make a backup copy. Other files print the book and make a backup copy. These scripts are in effect new UNIX commands through highly specialized to me and this particular book. Such personal commands are common use of shell scripts, a way to create shorthands for one's own frequent computations. If I still use some scripts that I wrote 30 to 40 years ago, and this is not at all unusual among the long-time Unix users. The final step in making shell programs fully equivalent to compiled programs was to make it so that if a file was marked executable, it would be uh, passed to a shell for execution. If a file was marked executable, it would be passed to a shell for execution. In this way, shell scripts became first-class citizens, indistinguishable from compiled programs when they were executed. Like this run check on this book. Shell scripts do not replace compiled programs, but they are an important part of programmers' toolkit, both for personal use and for larger tasks. If you find yourself doing the same sequence of commands over and over again, then you put them into a shell script and thus automate away from drudgery. If a shell script proves to be too slow, it can be rewritten in another language. We will see more about the power of shell scripts as we examine pipes in the next section. And that, I guess, is going to be today only 30 minutes of stream, but that is okay because I might sleep during the stream. And yep, from tomorrow we will start again like a regular. I do not have my exams tomorrow, so that is cool. And Yeah, I guess this was it for today. At least I showed up, which counts, which actually fucking counts. Just showing up, and I showed up, so I do not have to be too brutal with myself and accept and try to improve now. And showing up is okay, and I also have to be smart about it and not be too pedantic and too strict. I have to be smart about it, and yep, this is it for today, and bye. Um, Tomorrow I will start with the CE streams and then of course the Unix stream. Yeah, that is it. Kind of totally it.